Hello and welcome back. This is part 2. These notes can be found in my math lab under the tab Class Notes under Chapter 1. So this is Chapter 1, Part 2. So we have more definitions to go through. These ones are categorical, which is qualitative, I'll talk more about that in a second, and quantitative. So our first definition here is quantitative. Data. Quantitative data consists of numbers representing counts or measurements. You can see the word quantity in there, and that's exactly what it is. It's an amount. This is versus categorical. Data. Now, categorical data is something that consists of names or labels that are not numbers representing counts or measurements. So what happens is, between these two, one of them has to do with numbers, and the other one has to do with things that can't be represented with numbers. And so let's practice a little bit. The ages of survey respondents. Well, ages involve a number, so that's definitely quantitative. Political party affiliations, like Democrat, Republican, Independent, and so on. This is definitely going to be categorical. An alphabetized list of synagogues in a certain country, that's definitely going to be categorical too. We can't really assign a number to an alphabetized list, so this is categorical. And blood pressure readings from a group of cancer survivors, that definitely involves numbers. That's quantitative. Categorical sometimes is referred to as qualitative as well. You'll see that word, meaning we're talking about the quality of something versus the quantity of something. Speed that up a little. All right, a few more definitions. Discrete data. Result when the number of possible values is either finite number or a countable number. So for example, there is a discrete number of students in this class, meaning I can go to my roll book and I can count the number of students that are in this class. Continuous would be like water, would be more continuous. That's what our next one is continuous. Result from infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps or jumps. This one's a little harder to visualize. So if I were to say a person's height, would that be discrete or would that be continuous? A person's height, so let's say a child is born at 20 inches, exactly 20 inches long, and today they're 64 inches tall. Well, that means that they were every single height, all of them, between the 20 inches and the, whatever I said, 62 inches, as they do that. Meaning there is always a number in between. So you find any two numbers, 20.00001 and 20.00002, there's actually an infinite number of numbers between those two numbers. That's continuous. It's kind of hard to visualize, I understand, but it's when there's no gaps. Next up, we have nominal. Nominal is when numbers used have no value and the order of the list is irrelevant. And we'll do some examples of those in just a few minutes. The other one is ordinal. Ordinal result when numbers in the list are irrelevant, but the order matters. And again, we'll do some examples of that. So here's kind of how this works. The quantitative. So we have data, and we have the quantitative, and that breaks up here and here. So these two are the quantitative. These two are the qualitative or the categorical. So you can see here. And here. So let's see what this means, so we can get a better idea of what we mean by all of this. Let's do some practice. So we're going to classify this either as discrete, continuous, nominal, or ordinal. So religious affiliation is definitely nominal, meaning the order is irrelevant. Now, we could artificially put them into alphabetical order. The problem is when we go into another language, sometimes that order changes. So even though we can force an order to it, there really is no order to this, and definitely no numbers attached. So the numbers are going to be the quantitative, the discrete, or the continuous. There may be numbers with these as well. We'll see what we mean by that. The number of goldfish in a pond. This is definitely discrete, because goldfish in a pond can be counted. Now, it may not be physically possible to count them, but we know that there is a finite number of fish in any given pond. The weight of a goldfish. Now, this is going to seem a little weird, but this is sort of like when I was talking about the height, where every single number in between, this is definitely continuous. Because when a fish is born, not born, but when it comes out of its egg, it's a certain weight, and it is every weight between that and its heaviest that it ever gets. It's all those weights, all infinity of them. Nationality, that's definitely nominal. And again, we could artificially make a list, but the problem is if we were to make a list of different nationalities and we were to say Spanish was one of those, from Spain, the problem is someone from Spain, in Spanish, you pronounce it España, which means that it starts with an E, so that changes that as well. So again, we can artificially set up an order, but just nationality in general is nominal. The age of the oldest child, this is definitely continuous. That's kind of hard to visualize because we think of age of a child, an oldest child is 7 years old or 9 years old or 12 years old. But we all know that that 12-year-old isn't exactly 12 years old. It's going to be 12 years in a few months, weeks, days, nanoseconds, right? And then that's changing all the time. And so every time in between is also counted. So that's why that's considered continuous. Goals scored in a game. That is definitely going to be discrete. Very countable. Number of goals scored in a game. Up a little bit. Zip code. Now here's sort of a weird one. Zip codes involve numbers. However, the order of them are irrelevant. So this is nominal. Let me explain a little bit better. So if you get any given zip code, one is not better or not better than the other. And the numbers themselves have no meaning. Meaning if my zip code is bigger than your zip code, that doesn't mean that mine's better or yours is better or whatever that means. So the order is irrelevant and the numbers themselves actually are irrelevant as far as we're concerned. Water temperature. That is definitely continuous. Meaning water temperature, if water is 12 degrees Celsius and then it's 12.5 degrees Celsius, that means it was every temperature between those two numbers, all of them. Height, again, is going to be continuous. I talked about height earlier. Here's another sort of unusual one, the Jersey number. The Jersey number is a number, but again, the order is irrelevant, so this is also nominal. Meaning if someone has a Jersey number of 10 and someone else has a Jersey number of 11, that doesn't mean that the one with the 11 is better or more important or whatever than the one with the 10. So the order is irrelevant and the numbers themselves really have no meaning. Number of cats is definitely discrete. Meaning we can count a number of cats. You may want to go back through those. This can get a little confusing, especially the continuous part. So assigning a level of measurement to a variable. So we have 4 definitions here, and we're actually going to use 2 words that we've already used. This first one here is ratio. So these are levels of measurement that we're looking at here, and the ratio level of measurement is a level of measurement where there is a natural zero starting point and that the ratios are meaningful. So if we take something like salary, there's a natural zero, a salary of 0, And in addition to that, we have, if I make 20,000 a year and you make 40,000 a year, that ratio is a 2-to-1 ratio, meaning you make exactly double what I make. So that ratio has meaning. 3 times what I make, 4 times what I make, and so on. That's what a ratio is. Next one up is interval. Again, is a level of measurement that have differences that are meaningful, but there is no natural zero or starting point, and the ratios are meaningless. If we take something like temperature, there's no natural zero. We know that because the 0 in Fahrenheit is different than the 0 in Celsius, which is different than the 0 in Kelvin, which we're going to ignore that one for now. If something is 20 degrees and something is 40 degrees, that doesn't mean that it's twice as hot, if you can understand what I mean by that. And we'll come up with another example of those a little bit later. But in this case, the ratio between numbers is irrelevant. And there's no natural zero. Number 9 is ordinal again. We had that up here. Is a level of measurement where the data can be arranged in order, but differences either cannot be found or are meaningless. And we have an example here. Colleges in the US, they assign an order, but it really has no meaning. And last one is nominal. Is a level of measurement where that are categories only. Data cannot be arranged in an order. And this is a perfect place to do a little practice with that. Let's see if I can keep everything in this way. We can. All right, so we're going to try to figure out which of these 3 levels of measurement they are. We're going to start here. Sweatshirt sizes of small, medium, and large. Well, definitely there's no numbers attached to them. And the order does matter, meaning small and medium and large, there's a natural order, so this is ordinal. Next up is nationality. Once again, that's nominal. Meaning the order is irrelevant and we can't assign numbers to that. Meaning there's no natural zero or anything like that. Salary I mentioned before. Salary is definitely ratio. Again, for the reasons I mentioned before. So you could make 2 times the amount of money that I did. You can make 3 times the amount of money that I do. And there's definitely a natural zero of $0. Year of birth. So this is an interesting one. Is definitely interval. We think of years of birth where there is a natural zero, meaning year 0, year 1, I guess it would be. That actually isn't it, because if we start thinking about things in where this civilization existed 12,000 years BCE, then the 0 gets a little muddy. Like, where do we put that 0? So year of birth is definitely interval, and there are other places that don't use our Gregorian calendar. Volume of water used, that's ratio. I know this because I can have a 0 volume of water. And if I have a cup of water, and my wife has a cup of water that has twice the amount of water in it, that ratio is meaningful. Here's a controversial one, dog breed. My office mate has a poodle. But this is still nominal. Meaning the order is irrelevant. And again, we can induce something artificial if we needed to, by listing them by an alphabetical order or something like that, where there would be an order. But that's something artificial that we're putting on that. And again, if you just think going into another language, that order is going to be completely different. Year in high school, meaning freshman, sophomore, junior, senior, that order does matter. And there's not numbers attached to that. That's going to be ordinal. The age of a student. That is definitely ratio. I know this because the age of a student is 0 when that student is born. And then the age, it includes, we could say that a 10-year-old is half the age of a 20-year-old. And that ratio has meaning. That 10-year-old is 1/3 of the age of the 30-year-old, and so on. So there's a natural 0, and the ratios have meaning to us. Water temperature, as I mentioned before, this is interval. And for the reasons I mentioned before. And then height of an oak tree, that is definitely going to be ratio. When that oak tree first starts, when the seed starts coming up out of the ground, the height is 0 right when it starts breaking the ground. And then from there, it's every other height all the way up until its current height. So height is definitely in the ratio category. Once again, you may want to go back through these and try these again on your own to see how well you do, and maybe even come up with some of your own.